This video is about relating two quantities using a graph. Let's talk about an example. What is likely to be true about your speed as you go from the bottom of the ski slope to the top? So we want to relate two quantities. We want to relate where you are on the ski slope versus how fast you're going. And how the graph looks will depend on how you assign your axes. Notice I have my y-axis labeled and I have my x-axis labeled. Let's consider the y-axis our speed, and let's consider the x-axis our position in the slope. So speed, and we'll call over here will be top, and down here will be bottom. So as you go across the x-axis, you're going from the top of the ski hill to the bottom of the ski hill, and as you go from the bottom of the y-axis to the top, your speed is increasing. So let's think about what happens when we're skiing down a ski slope. Well, when we start off skiing, we have relatively little speed, and then we gain speed as we go down. So I would say our graph would look something like this. Now, obviously, that's a gross generalization, and we're not taking into consideration that perhaps your rate of change of speed might change over time. Perhaps you would, gravity is actually an acceleration, so your speed might actually increase at a faster rate the more you went downhill, but then there's gravity and changes in topography and all sorts of other things that would alter the look of this graph slightly. But in general terms, your speed is going to increase as you go from the top of the hill to the bottom of the hill. It might, if you want to be more particular, at some point level off to say, you're going to get up to a certain speed and then you're going to stay at that speed based on the control that you have skiing or the friction you have with the ground or any of that kind of stuff. So it could look something like that. But generally what we're looking for here is the fact that as your distance from the top of the hill to the bottom of the hill increases, your speed increases as well, obviously until we reach the bottom of the hill, at which point it stops relatively quickly and we slow down. Another example of two different quantities would be the temperature of water and the depth of the water. So if you've ever been in an ocean or a large lake or even a large pool, you might notice that the water at the top is warm. It's closest to the air, which is usually warmer than the water temperature and being exposed to more sun. As you go deeper in water, it gets colder because obviously it's further away from the air and it's getting exposed to less sun and less sunlight, so therefore it's not heating as much. So how would we relate a graph like that? Well, we might first want to label our axes, and we're talking about temperature and we're talking about depth. So as your depth increases, what happens to your temperature? Well, when in the very shallow waters, your temperature is relatively warm. But as you get deeper, the temperature goes down. Just like in the last graph, this is a generalization, right? There could be lots of variables to figure in here, and that would change the look of this graph slightly. But generally, as you go down, as you get deeper, your temperature goes down. And this is what graphing two quantities on a graph and relating them looks like. You have to assign your axes, and you have to decide, okay, what's the behavior of this thing given the relationship between these two pieces of data? The previous two examples were fairly linear graphs, meaning that speed was fairly consistently increasing as we went downhill, temperature was fairly decreasing as we increased our depth in the water, all in sort of a linear progression. But let's talk about a graph that maybe isn't linear. What about the temperature outside related to time of day? So again, we want to label our axes. This time the x-axis is going to be time of day, and the y-axis is going to be temperature. Let's talk about when in the morning, let's say 12 a.m., right when you wake up, 12:01, it's relatively cool outside. Maybe not now, maybe now it's still in the 70s, but it's cooler than it will be later on in the day. So, we're somewhere here. As the time increases, is to say 6 o'clock, temperature goes up a little bit. As we get closer to noon, temperature increases more up until we reach about 5 o'clock, and then temperature starts to come back down. So this graph, you'll notice, is not linear. It changes based on what time of day we're talking about, and it's got this sort of big arc in it, this big curve in it. It goes because the temperature changes, the direction, the rate at which the temperature changes, and the direction the temperature is going changes over time. So that at about 5 o'clock, we get this peak in our temperature about 5 p.m., and then the temperature starts decreasing again to the next day. So you can see that not all these graphs are going to be straight lines. Some of them are going to change direction depending on what we're talking about. In this case, temperature and time. You could also talk about things you buy. If you were, the total cost, if you were to go to a 2-for-1 sale, let's say, for shirts, and you were to buy 2 shirts for the price of 1. Well, the price of 1 shirt would be at a certain place, but then when you go up to that next shirt, all of a sudden the graph is changing again. So there's those kind of things, relating 2 quantities on a graph like this. And I want you to really think about, what is this picture going to look like? There is a tendency with things like skiing to just draw a picture of someone going downhill. I'm thinking that's sort of what they're meaning, but that's not what you want to think about. What you actually want to think about is the numbers that we're talking about. 5 o'clock, time increasing, time going on during the day versus temperature going up and going down. That's the kind of stuff you want to think about. And then how would that look like on a plotted graph? And I'm not talking about specifics, but I am talking about generalities. Do we see a general correlation of increasing or decreasing, or what's the pattern of the data?